So this is the second lecture. We'll be studying about a very important thermodynamic cycle called the Rankine cycle, and the power plant which we saw earlier, that is the coal based power plant or the thermal power plant, works on this cycle. So these are the contents. We'll be seeing about the introduction and definition, types of cycle, ideal Rankine cycle, reheat cycle, regeneration Rankine cycle, and why we use a Rankine cycle, and finally conclusion. So this is Rankine, and he is the person behind the Rankine cycle. He's basically a Scottish civil engineer, and along with him we have Clausius and William, who contributed to the development of this Rankine cycle, and they are also responsible for focusing on the first three laws of thermodynamics. And I hope you guys believe and remember what are the three laws of thermodynamics. The Rankine cycle is a cycle that converts heat into work. Heat is supplied from externally to a closed loop system. Again, we studied about closed loop system in thermodynamics. You will know what is closed loop system, which basically uses water. Most of the power plants in the world operate on this cycle. So these are three types of Rankine cycles: the ideal cycle, the reheat cycle, and the regeneration cycle. So this is the process which is represented. We have the heat exchanger. This heat exchanger is basically a condenser which is in the power plant, where heat is thrown out of the system. Then we have the compressor or the pump, which pumps the water inside the power plant, where the pressure of the water is increased, and then it passes through the boiler, where heat is added to the system, and from boiler to the turbine, and in the turbine work goes out of the system, and finally it comes to the heat exchanger or the condenser. So there is a little bit of work which also goes into the system in the compressor. So there are basically two types of process in thermodynamics. One is the reversible process or the non-reversible process. The reversible process does not have any kind of loss, so it can be reversed. And an isentropic process is an example for a reversible process. And the process where we have a lot of friction, or there are some kind of losses, then those processes are called as non-reversible process. So in a real Rankine cycle, the compression by the pump and the expansion of the turbine are not isentropic or not reversible. And entropy always increases in these two processes. And we already studied in thermodynamics, whenever there is an increase in entropy in a process, that particular process cannot be reversed because it violates the second law of thermodynamics. So this is the energy analysis. We have a diagram here, and there is a white curve. So this white curve is your water steam balance curve, or all the area above this white curve is steam, and inside the white curve it is water. So we have a blue line which represents the process. This is process 1, that is pumping, and this is the process 2 to 3. It goes to the boiler. Okay, it gets heated and converted to steam. So this is where it converts to steam, and this portion it is steam. And this is your turbine process. In the turbine it is expanded, so whenever it is expanded in a turbine, energy is lost. Finally it comes to this position, and this is your condenser process, where it comes back to the original position. So this is the energy balance equation, where there is net heat transfer in through the turbine, it happens here, then minus the net work output we get in the compressor, and then next the energy flow which is happening in the pump. We normally use a pump. So this is the energy balance equation. Q in is the heat supplied into the system, Q out is the heat goes out of the system. Where heat is supplied? Heat is supplied in the boiler. When you burn the coal, heat is supplied to the boiler, that is Q in, and Q out is the heat which goes which actually goes out. So where Q goes out, there is some amount of steam or some amount of energy which goes out from the cooling tower. So this is where the heat goes out. So what is work output? Where we get work output? The work output we normally get it from the turbine. And what is the work input? We normally use a lot of pumps to pump the water. So that is the work input. And HIN, what is HIN? That is the enthalpy which we normally get, or the enthalpy of the incoming water, and H out is the enthalpy of the outgoing water. So this is the energy balance and thermal efficiency equation. Finally, net work output divided by the heat put inside. The net output work is the H4 minus H1, the energy of the outgoing water, the energy of the incoming water, divided by H3 minus H2. So this is the W net, that the work output minus work input. So these are the developments in the Rankine cycle, because the actual Rankine cycle is not, uh, you know, the reversible process based. It is actual process based. So there are basically two types of Rankine cycle. One is the reheat cycle, and the second one is the regeneration cycle. So this is the reheat cycle. In reheat cycle, basically we have two turbines, and in between the two turbines we have a boiler. See, the pump pumps water to the boiler, steam goes to the first turbine, and after the steam comes out of the first turbine, the energy of the steam will not be sufficient to run another turbine. So the steam goes again into the boiler and it gets reheated, and this reheated steam runs the second turbine, and then that reheated steam again comes out of the second turbine as a low power steam, and then it is condensed and the cycle continues. So this is how uh, it is represented in your HS diagram or TS diagram, and this is your input, that is your pumping here, and here it is heated in the boiler at a very high temperature and then converted to steam here, and this is the first expansion process in the steam. Then again it goes to the boiler and gets heated, and then there is a second expansion of the steam in the second turbine, and then this is the condensation process. So this is the energy analysis. This is Q in, that is Q primary, the initial heat supplied to the steam, plus the reheat heat. So finally you have H3 minus H2 plus H5 minus H4. Work output is the work output of both the turbines, that is H3 minus H4 plus H5 minus H6. So this is the thermal efficiency, work done by the heat supply. So here we have the regeneration cycle. In regeneration cycle, the heating of the water takes place in two stages. That is the first stage in the economizer, or we use the waste heat which is coming out of the turbine to heat it, and then we have the second stage where higher temperature heat addition is done. So two stages. So this is the second stage of heat addition. So this is how we have a pump, we have a boiler, and we have another pump. This is the open FWH. So what happens here? What happens here is the pump supplies to the open FWH or the preheater, where the steam enters, the waste or the steam which comes out of this enters, and also the inlet water enters, but they don't actually mix with each other, but only the energy is supplied from the inlet, the energy is supplied from the exhaust steam to the inlet water. So the water is heated, and this heated water enters the